Hello, my name is Kelby Kramer, and this is a presentation of my 15110 term project. For my term project, I have decided to create a traditional Chinese board game called Go. For the game of Go, there are three different board sizes. There is a 9x9 board size, there is a 13x13 board size, and then there is the traditional 19x19 board size. So the user is first greeted with the basic rules of Go along with an interface guide. I'll just go over the rules really quickly. The game of Go consists of two different players, black and white, and they take turns placing stones on empty vertices. Stones, or groups of stones, must have at least one empty adjacent vertice, or else they are captured or dead. The goal of the game of Go is to surround as much territory as possible, and a player's territory are essentially empty vertices that their stones surround. A player can pass if they feel they have no advantageous moves left. And then at the end of the game, dead stones are stones that would likely be captured if the game were to be continued, and they must be removed from the board. I won't go over the user interface here, so I'll go ahead and click Start. As you can see, when we first enter the game, we're greeted by our 9x9 grid, and it starts as black's turn, and you can see that because the header up here for black is highlighted and the cursor stone is black. We also have a main menu button that would take you back to the main menu. I have an admin mode button, which we'll talk about here in a second. You have the capture count for both players underneath their header, and right now, because it is black's turn, black also has a pass button that they can go ahead and click here. So when I click on the board, you can see that that black stone was placed, and this black up here is no longer filled black. That's because it's white's turn. And you can see white has become filled, and my cursor stone is now white. And I can go ahead and start placing white stones. And the game automatically goes ahead and changes turn here. I can't place stones on top of other stones, and I can't place stones off the board. But if you see right here, this black stone only has one open vertice left. So if I, as white, place here, this stone will be captured because it has no more vertices open. So you can see that when the stone was captured, it got removed from the board, and white's capture count over here went up by 1, and it changed turn to black. And another thing to note about the game of Go, I am not allowed to place a stone here because it has no open liberties to go to. It is surrounded by black. So if I try to, the game will tell me, oh, that's an illegal move, please try again. And that'll go away as soon as I move my mouse. That's only because black is surrounding these stones. For example, if I try to place a white stone here, this is actually a legal move because it is touching its own stones, and its own stones have an open vertice out here. So I can go ahead and place a white stone there with no problem. Similarly for black, can't place one here, can't place one here, but I can place one here. So let's say the game progressed nicely along, and white feels like, okay, I have no more advantageous moves now. I'm going to go ahead and pass. But black says, hey, wait, I still feel like I can go ahead and grab this little territory right here, so I don't pass. So the game didn't end there, and it still won't end when white hits pass again, because players have to pass consecutively. So now if black is like, okay, I don't have any more moves left, I'll pass, boom, the game is over. I can no longer place stones on the board, but it does ask me to click dead stones before scoring. And so dead stones are these two stones right here, because black would probably eventually capture this white stone, and white would probably eventually capture this black stone. So when I click this stone, it's going to remove it from the board, and if you saw up here, it also added one stone to the black capture count, and if I click this black stone, it'll remove it from the board, and it also added a stone to the white capture count. So it knows which stones is being captured by who and which color they are. So now I'll go ahead and say, okay, we're done. We'll go ahead and score the game. And instantly we get this nice score screen that says black has 16 and white has 18.5. This 0.5 here comes from something called Seki, which is given to white because they have a disadvantage by going second always. And it says, oh, okay, white won. So I'll go ahead and hit main menu, and that will take me back to the main menu. Let's go ahead and talk about admin mode here really quick. So admin mode was something that I created so I could basically debug, and what it does is it no longer passes when a stone is placed for a player's turn, so I can place as many black stones as I want. I still can't place stones on top of each other, and then I can also go ahead up here and click on the white, and I can click all the white stones I ever desired. I can also go ahead and remove stones by clicking remove stone here, and you can see the remove stones toggles to red because I'm now removing stones. and I can go ahead and remove all of these stones. And then I'll toggle that back off if I want to place some more white stones. Just to try some stuff out and make sure this captures. Cool, it captured. One more thing in admin mode is that if I hit G, I go ahead and toggle the hitboxes for all the vertices, so you can see that this is the actual hitbox for this vertice. And then another thing is that if I want to get rid of this cursor stone here, I can go ahead and press O, and then I no longer have to see that. And then I can go ahead and return to main menu, and I'm back to the menu. So now I'd like to talk about what was really the fun part about this project, and that was having to use recursion to kind of make the rules work. So right now I'm actually in the traditional size board. This is 19 by 19, and I've created this kind of ridiculous shape in admin mode just to demonstrate kind of the capabilities of recursion. So like I said earlier, I can't kill myself. So if I try to go right here as white, this actually won't let me go there because it's gone out to all of these and it knows, okay, all of these do not have liberties, and it does that recursively, going to each stone and checking. So it knows that I can't place a stone here. Similarly, it also knows that, say, if I put all the way down here into this corner, I can place a stone here because it knows that there are open liberties to go to. Here is a nice example. So if I try to place a stone here, this is an open liberty for all of these black stones, and this is an open liberty for all of these black stones. So if I try to place a stone here, it's not going to let me do that because it's checked all of these black stones all the way out, and it found here that it has an open liberty. But if I go ahead and I block that off, and I try to capture these now, this will be a legal move because I will be capturing all of these stones because this is the last liberty left. And so it'll go ahead and let me capture all those stones, and look at that, I just captured 132 stones. That was a lot of fun. One of the other functions that uses recursion is actually the scoring function here. Empty vertices are checked to see whether they're white or black territory. This over here is neutral territory, so is everything out here because there's a black stone here, and this is also a neutral territory because there's white stones in here. Ideally, we would go ahead and remove those stones if the game was over, but I'm going to go ahead and leave them in there to make this math a little easier. I'm going to remove this dead stone, so white should have 6 plus Seki, that gives us 10.5, and then black should have 3, but minus 4 here, black will actually end up with -1. So there we go. It worked perfectly.